Hey guys, this is Miss Stratton. I just want to go over the questions that you added on our number 2 assignment. Um, but first, I want to talk a little bit about the assignment itself. Now, let's look at this. So, it asked you to write down one thing that you learned and one thing that you still don't understand. It also says to answer those in 2 complete sentences. Y'all, you're in 7th grade. This is your 8th year in school. You know how to write complete sentences. However, many of you did not do that. This is the only time that I will give you credit for not following those instructions. Next time, you'll only receive partial credit. Another thing, I have a different screen than you do, so I can't show you, but you need to put your answers in the little answer box. It's on the right-hand corner. Do not put them in the class comments. All right, so in the future, make sure you put your answer in the correct place and also use the correct format. All right, so let's go ahead and start addressing some of the questions that you asked. So the first thing we're going to look at are the parts of an atom. So some of you asked about the different parts of an atom. So atoms are made of protons, neutrons, and electrons. We have protons and neutrons here in the nucleus. Protons and neutrons are much larger than electrons. So this model that we have right here, the scale is so far off, and it leads to lots of problems with how people understand atoms. So really, this should be much further apart from this, and the electrons should be much smaller. Another thing that people had questions about were how to figure out the number of neutrons. We actually have an ed puzzle you're going to be assigned this week that's going to address that very thing. So the way we find the number of neutrons is subtracting the atomic number from the atomic mass. But that's not something we've really discussed yet. I don't expect you to know how to do that yet. So in our atom, we have positive protons, neutral neutrons, and we have negative electrons. Somebody asked about why we have neutrons if they don't have a charge. Really, it's just there to contribute to the mass and determines which type of that atom we have. So when we have different forms, different numbers of protons in the same element, that's called an isotope. Another question we had is, how is an atom mostly made of empty space? And someone even said, why is it not just full of air? So the reason that this is mostly empty space is because we don't have particles smaller than an atom that can be in between those things. So we know that an atom is the smallest unit of matter with its own properties, and so there's nothing small enough to go in between those pieces. And when we say that an atom is made up of mostly empty space, that means that most of what's within the atom is nothing, is empty space. That doesn't mean that it doesn't have parts that are required for it to be together. It just means that they're really far apart and there's nothing in between them. All right, now let's look at magnesium. So I had several questions about atomic mass and things like that. So this is the element magnesium. This is what its block on the periodic table looks like. And this number at the bottom is the atomic mass. The atomic mass of magnesium is 24 and 305 thousandths. And this number is a decimal, you'll notice. And that is not because we have pieces and parts of protons, neutrons, and electrons. That's because this number right here is an average. And the reason it's an average is because we have some magnesium atoms that have 13 neutrons, and we have some that have 12 neutrons. Every single magnesium atom is going to have the same number of protons. All magnesium atoms have 12 protons, but we can have differing number of neutrons. So they take a sample and they come up with the average mass. So it's just like when you're in math class and maybe you're doing some averaging and you wind up with an answer that has a weird decimal that may not really make sense. That's sort of what we're dealing with here. So just understand that this number is an average. Another question I had was about this cube. That's not something you're going to see on the periodic table very often, but when we learned about the periodic table, you'll see that there are lots of different forms of the periodic table. And this here just happens to have an indicator for the state of matter. That's what this is indicating. So magnesium is a solid at room temperature. If this was hydrogen, it probably would have had a cloud or something like that to show that hydrogen is a gas at room temperature. If it were mercury, maybe it would have had a droplet of water or something like that to let you know that mercury is a liquid at room temperature. So that's what that box is. Again, it's not very common, but it's something you may see on occasion. Somebody else said they don't understand how to read the periodic table. That's fine. We're not there yet. That's going to be what we learn here in the next couple of weeks. All right, that was really all the questions that I saw. Bye, guys.